Yes, and up next we actually have someone who's been part of this entire OpenStack journey with us. He's given a lot of really interesting keynotes at previous summits, and so from our first headline sponsor, Canonical, we want to welcome the CEO and founder, Mark Shuttleworth.
Well, what an amazing year, what an extraordinary year this has been. I really do miss the excitement of an Open Infra Summit in person. But on the other hand, it's quite nice to be speaking to you today from my office, which, as I'm sure it is for many of you, is also my dining room. So what I wanted to talk about this morning was OpenStack operations. Because the key thing to get right with OpenStack is the operations, not just deployment, but also upgrades, expansions, integration, evolution. A successful cloud will live a long time and will need to grow and evolve during that time. And I speak to you with a perspective now from Canonical of having delivered hundreds of different OpenStack clouds to different customers. Building OpenStack clouds for customers is a key focus for us. And of course, every customer has their unique requirements. So this gives us quite a unique perspective on successfully operating OpenStack. Now, of those clouds today, right now, 58 are fully managed by Canonical. And avoiding operations altogether is the easiest way for you to assess the value proposition of OpenStack and make sure that you're able to integrate with it and get the most value out of it. But the thing that I'm most proud of is that over the past couple of years, 25 of the clouds that we have been fully managing have been transferred into customer hands. It's really important to me and to us that customers take full control of their own clouds and start to build more OpenStack themselves. Giving people the confidence to do this is the key, and giving them the tools to do this is the key. It's not just about deploying OpenStack and living with an OpenStack. It's about running an OpenStack which is in under heavy utilization and doing all those things that people say are difficult. Now, for us, the secret sauce in this case isn't a secret. It's right there in the upstream OpenStack repositories. And that is a portfolio of reusable operations code packages. So this is charmed OpenStack. Each of those pictures represents, each of those icons represents a package of operations code. And every single deployment that we do, even if they have different architectures on different kinds of hardware with different goals and are in some cases choosing different components at different scales, every single one of them reuses the same packages of operations code. And they get updates to that ops code whenever something is fixed for anybody who shares that same body of code. Now, charms are packages of operations code. Now, the engine behind that is something called Juju. And Juju is not a configuration management system. If I look back at the history of configurations management systems, back in the 90s, we had CF Engine, Puppet came along in the early 2000s, Chef came along a little bit later, and Juju was launched after that. And the interesting thing about Juju is that it is an application management system and a model-driven operations system. It's not a configuration management system. It allows us to encapsulate and share packages of operations code, preferably as open source, and not just operations code, also integration code, so that each different deployment is reusing the same raw materials. The beauty of that is that entirely different OpenStack clouds can reuse those packages and benefit from all of the bug fixing and insights that are being put into those different components effectively. So this is how we wrestle with OpenStack. It's an incredibly powerful idea that has helped Canonical tackle many of the most complex projects in modern scale-out open source. We can share operations code packages, and we can compose them to make what look like unique deployments that still get updates and upgrades. And that's how we manage so many different OpenStack deployments and deliver them so cost effectively. This is how we tame complexity. It makes tailored and optimized OpenStack on specific hardware very tractable. Now, that's really important for a large OpenStack environment, and most of the bigger customers are building large OpenStacks. You may have heterogeneous hardware, you may have heterogeneous networking, and you need to be able to wrestle with those components. But not all OpenStack clouds need to be complex. And today I want to focus a little bit on the emerging area of edge computing. The term edge is a bit confusing. Even within a single company, there are many teams with different edges. So we think it's better to describe two classes of compute, the Internet of Things and microclouds. Microclouds are tiny clusters that are typically reproduced across an organization in hundreds of locations. And you can add microclouds to your private clouds and, of course, your public cloud to create the enterprise compute continuum. And so microclouds are a new class of cloud in the enterprise compute landscape. And I want to talk a little bit about OpenStack in the context of microclouds. The challenge, of course, with microclouds is that you don't just have one of them, you have hundreds of microclouds. This is at the remote office, branch office, warehouse, distribution center, building maintenance office, cell tower cluster. And so the question is really how to make it easy to operate OpenStack in this sort of world. We're not trying to mix lots of components here. We're just trying to get a highly repeatable deployment of OpenStack together. There's not a lot of complexity, but there is a lot of fragmentation and scale. So what do? Let's start with a single node OpenStack. And a little while ago, we introduced you to MicroStack, a single package OpenStack. With just 2 commands, you can install MicroStack and then initialize it. And as a developer workstation on that machine, you now have an entire OpenStack on that workstation. And this has become quite popular. Anyone with a spare server or workstation can have an OpenStack endpoint to play with, and it's literally 2 commands to set up. So what's the next step? The next step is to add some nodes. And first we install MicroStack on one node, and then we cluster that through 1 command on the original node, 1 command on each new node, and we form a tiny on-rails OpenStack cluster. And so this is now the simplest possible multi-node OpenStack cloud, and it is perfect for the microcloud environment where you may have many, many deployments, but you want them super simple and on rails. So super simple microclouds. There is a breakout session today at 10:45 Pacific time, which I would encourage you to dig into if you want more details on that. So let's go back to that idea of wrangling complexity, and let me finish the story of Juju. So we launched Juju into a world where you had Chef, and then along came SaltStack and Ansible. Juju, of course, stood apart because it wasn't a configuration management system. It's an application management system. And then in the world of Kubernetes, a really interesting thing happened. Configuration management doesn't work there. And so we've seen lots of people playing with similar ideas. We saw Tosca, we saw the Mesos frameworks, we saw CoreOS with operators, and a variety of operator frameworks and lifecycle manager. And so finally, this is really an idea whose time has come, right? So Juju implements what in Kubernetes world is now called the operator pattern. And it allows us to do really amazing things on Kubernetes as well. So this, for example, is Kubeflow, a really complicated set of microservices that together make a fantastic industrial scale ML ops platform. It's very difficult to operationalize without Juju, but Juju makes it really easy. So Juju is an operator lifecycle manager in Kubernetes speak. And what's interesting about it is that it is a universal operator lifecycle manager. It can handle bare metal, which is how we build OpenStack. It can handle VMs, and it can handle containers on Kubernetes. So if you've been paying attention, we can take bare metal. We can use Juju and operators to build OpenStack with all of that flexibility and all of that clarity of architecture. We can then take that OpenStack. We can use operators and Juju to build Kubernetes. And we can then take that Kubernetes and we can use Juju and operators, Juju as an operator lifecycle manager, and we can build things like Kubeflow on top of that Kubernetes. So we have this single beautiful way to model software across all of those three different environments. This has come together really beautifully. It allows us to integrate things on Kubernetes with things on OpenStack and with things on bare metal. If you want to learn more about that, there is a training day on Thursday, and we're going to run 3 sessions at different times for different audiences. For our Asia audience, we'll be kicking off 2 p.m. Shanghai time. For our EMEA audience, we'll be kicking off at 1 p.m. UK time. And for the Americas audience, we'll be kicking off at 2 p.m. East Coast time on Thursday, the 22nd. I hope you can join us. Come and build pure Python operators that are amazing for scale-out software and awesome for integration with other communities. Thank you. Have a great week.